So we're shifting gears completely with the previous talk. This will be more or less technical and more or less only applicable to people who are interested in doing technical and work on a terminal. So very different. So who am I? Pierre-David already said all of this. I guess the only thing I really want to plug here is Monterey Hack, which is our monthly security trainings, where we focus on doing hands-on CTF exercises. The other stuff is already plugged, besides the Hacker Jeopardy, which I will host on Saturday. So if you never came to the Hacker Jeopardy, you should come. It's free for everyone who is attending NorthSec. François is really proud. He's assisting me. We've been doing this for 5 years. It's a blast. It's really fun to do, and it's really fun to attend, I think. Hugo?
And yeah, for me, basically, Pierre-David just read my bio, so that's basically it for me. Polyhack, WAS Montreal, and PolyMTL. That's basically it.
All right, so today we'll see why, what, where, and say what of our talk. So since building machines take a while, like building complete Windows machines from scratch take a while, our demo is actually at the beginning of the talk, and you'll see the results at the end of the talk. So this is how we decided to do it. Let's just open up the shell here. Thank you.
Can I help you with that?
So here. Oh.
Does it work?
Nope, I have no internet. I think I should have internet in a few seconds.
So basically it works.
All right.
Nice.
So here we go. This is the tool, and now we're going to start it. And now back to the talk. This was the demo. We'll see the result at the end. All right. So, was there any questions? It's a cool tool.
Thank you, thank you.
All right. So, why are we building this? Okay.
Nice.
So I had no internet when I loaded the slide deck, so I need to refresh the whole thing.
Because it's really funny, so you really want to see it? Oh, good.
So here's the context. This is how we do malware analysis right now. It's manual. We throw tons of people at it, a lot of resources. Its individual tasks are relatively boring, and yet it is very impressive. Huge companies are building whole business model around it, and we really, malware industry really secures people. I know it's not trendy to say it right now, but I strongly believe that AV is kind of the belt in a car. You need one. Everyone has it. It's mandatory, and yeah. So that's the way I feel about it. But stuff like this, Go Secure cannot afford that. Like AV companies can afford that. So what I needed to do in order to scale at work is we needed to improve the tool chain in order to be able to do analysis quicker and spend less time micromanaging virtual machines. And so this is what this talk is about.
So for customization of the VM, it's kind of the same story here. We have vanilla XP VMs, or more recent version if you want to analyze a 64-bit sample. But that's basically the main story here. We see that a lot. No trace of a previous user. You don't have files. You don't have browser history. You don't have emails. You don't have anything on it. It's basically just an empty PC that has no user that has never been inside of it. So you have to manually customize your PC, and it's really time-consuming. It's really non-technical. So you just basically waste time. And it can lead to cross-infected VMs, and you can't build or reuse templates at all. You have to rebuild the whole system all over again when you try to do basically the same thing. And so, yeah, that's basically it. It's really time-consuming, and we could do much better.
I have a problem. I need to restart the whole deck.
And there goes my joke.
And there goes your joke.
Yeah, so basically, we would recommend ASCII.RevealJS backend. It's really good. He's one of the maintainers, so yeah, it works really great.
All right, now go on with your joke.
Okay, so it's time consuming, and basically the 90s called and they want their mythology back, and I have a funny GIF.
Putum. So other problems with malware analysis is it's not easily accessible to newcomers. So most of the people getting into this field, they need to get a book which is called Practical Malware Analysis. They need to read through it, and then they need to understand that they need to be really careful with live samples, that you cannot trust the VM once it's infected, and so on. So it's easy to mess things up. Teamwork is also hard. The tools don't encourage it. IDA Pro is not able to do any collaboration. There's not even a goddamn Control-Z on that tool, which is, I mean, in 2016, completely idiotic. But it's there, and it's what we use. So sharing VMs is also like sending files to each other and like, oh yeah, the sample is in that folder. Oh yeah, but oh, you like that tool? Oh no, it's not installed on my VMs. I don't use the Fiddler. I use like Wireshark out of the VM. So it's really just pain in the butt, in the neck. Building a credible environment is time-consuming, as Hugo was saying. Also, there are several ways to mess things up. Like if you install IDA inside your VM and the malware happens to be stealing IDA licenses, then oh, you leaked an IDA license to the whole internet. And everyone you meet at conferences tells you, oh, thank you for the IDA license, by the way, that was leaked from your company. So a lack of integrated or enforced best practices can lead to leaks like that. Now, when you deal with VM problems, this is how, where's my cursor? This is how you feel like. So it requires skills. So, oh, you foresee the problem. What do I need to do? How should I react? Okay, now I can fix this problem. That's perfect. Took me some time. And it's applicable only to one environment, one situation. Oh yeah, I managed that. Okay, good.
I'm good.
I'll be able to continue.
Yeah.
All right. That's fine. Okay, next debug, step. Oh shit, another problem. What do I do? Okay, oh, I can figure this out. Oh my God. I'm a genius. So we feel like heroes. Like, this is really the way we've been working, and it feels great. That's why the statu quo is still here.
And one other problem is malware auditors really want to know if they're being tracked or not. So there are a couple of ways to do that. One of them is an anti-VM like red pill, SLDT instruction. To just they kind of get their inside a virtual machine. There are probably analysis behind that. So they just don't want to run on that exit, and then nothing has been done. It's not a malware. But now some of them are not reliable in multi-core systems, and when acceleration is deactivated in virtual machine. So actually, they're kind of non always applicable. So other tricks, you can have anti-debugging. You can have debugger plugins to just pass that through, and the software, the malware doesn't see anything, so the anti-debuggers are completely useless. But what about system fingerprinting? Is there really tools for that? And that's what we try to get to. What's the next step if the VM is installed in an office, and in companies, virtualization on the desktop is getting more and more popular. So if you want to infect a VM, you don't want anti-VM. So what you can do is fingerprint the system if it's a good system to infect or not. Another thing is it's one shot, one kill for APD research, or basically You don't want to waste your time or your IP if it's not realistic. You just could get banned, your IP just blacklisted, and then you get nothing from the CNC, and so it wastes a lot of time another time. So it has to be credible and has to be fast, and you have to make it worth the first time you get into it.
So now that you saw the demo, what have you built? So we were inspired by the DevOps principle. So why should the DevOps people have all the fun? They are building great tools that changes traditional IT. No one is looking back. Like I heard of no one saying, oh yeah, the old way of doing system administration is nice. I take care of 7 servers and I'm a full-time employee, sysadmin, and I love this thing. But DevOps has applied a lot to Linux server, but what is going on the Windows ecosystem? Luckily, things have changed lately. So yeah, you go. Why DevOps?
So why DevOps? Basically, one of the core principles of DevOps is infrastructure as code. So basically, like Olivier gave me an example, like Git, and you just want to make something that is you can reproduce. So basically, if you do it one time, you can be you are able to do it every time. So you just don't have to do it all over again every now and then. So it's also, you can also throw away your VM, and then you have all the tools to build that really fast another time. And so it's really more efficient, and that's what we want to bring to malware analysis.
So continuing on our train analogy, let's see what is our inspiration if we're talking about building railroads. So this machine is building railroads. It was engineered by someone who took a lot of time to make railroad building easier and faster. So the human now, instead of 80 humans running around, there's now one guy who is inventing work. He has nothing to do. He's like sweeping dust to look like he's busy doing something. And this is exactly what I want when I build analysis machine. I want to see a terminal who is working and installing the tools for me, and I don't want to be doing anything. I want to be checking my emails, looking up on Twitter, reading the latest APT report I don't have time to read. Yeah. I don't want to be clicking next through all the tools I need installed in my VM. So we need to build something like that, or we built something like that for malware analysis.
So yeah, basically checking Twitter and checking emails is basically the malware analysis job. So you just want to do that and just being concentrated on that.
He was an intern at work. He didn't we didn't give him
any
real
did for
tasks.
Months, so yeah.
So yeah, you're a Twitter expert, social media expert now, is that
it?
All right. So what architecture did we use? Well, we reused existing DevOps tools. So the base image builder is Packer, which is a HashiCorp open source. It's all open source and free, of course. Then we use Vagrant to do the reproducible and operating environments and to manage, if you want, the infrastructure. This is all running on top of VirtualBox. So the VMs are, you have a GUI on your desktop when you spin the VM, when you build it. And you can do, once you have built with Packer one image, which takes half an hour, and a full disk I/O for half an hour because Windows, needs a lot of I/O to install. After this, you can do a Vagrant up, which is a snapshot, a quick on-disk copy, takes no space, and you can have several analysis in parallel. So leveraging all existing tools. And for remote management and install tools inside the VM, we use PowerShell through WinRM for Windows remote management. 2 years ago, all of this wouldn't have been possible. Vagrant didn't work on Windows, Packer didn't work on Windows. So I looked at this thing. I had this idea a few years ago, but now I re-investigated it last October and last November, and it was possible now. And I even borrowed some configs of Mark-Andrew Dwyer's, who built the Packer malware repository. And basically, I stole his unattended config.xml because I'm not a Windows person, so I didn't know anything. They weren't working for Windows 7, so I adapted them, but still, he really helped because he got me started. Another giant where we are on top of is Chocolate, which is the apt-get for Windows. Now our tools is bootstrapping a Chocolate install, and then we use all Chocolate packages to install sysinternal tools, WinDBG, and all of the stuff, Fiddler, and all of the stuff we need to use. So this is all thanks to the giants that we are standing on. And the thing is, why are we the first to do it? I think no one cared because everyone likes to be the hero, the one throwing the wood and saving the day. And so no one has done that before. And because malware analysis is such a niche environment that it was not really useful or anything, people prefer to manage their VM their own way. So tools are automatically installed based on profiles, which are part of the tools, and we install all of this, which I already mentioned. So this list is just only limited by your imagination, and you could customize it. And I mean, this is all open source. So now, dealing with VM problems looks like this. Whoops, the GIF will rotate, and you will understand the beginning of it. But so when you have a problem, what you do is you either restart from scratch or you plow through it. You just don't care. It's not, your VM is not a cute kitten, it's a cattle. You kill it and you get another one. So this is a concept of the DevOps industry about killing cattle and petting kittens. Anyway.
So what you can do with that afterwards is put your malware into context. So basically, it maybe behaves differently in different environments, if it has a domain attached to it, if it has a couple of VMs. So you want to build that as efficiently as possible. So if you know, for example, the target of the APT you're trying to track, you don't want to have a VM that looks like a vanilla one. You want to have a VM that basically looks like an employee of a Russian company or government or something like that. So you want to put your malware into context, and when the bad guys arrive, they just see smoke, and they're basically, oh yeah, that's the one we want to be on, so we're going to put stage 2 on that, and then you get another sample, and your research is better. And do that in as little time as possible. So what are the use cases? One of the investigation I did last summer at ESET was Win32 Syndicasec did manual recon. It lists a lot of things. It did last open files, directories, what's on the desktop, and ran system info to get install date, hardware info. So basically, in a couple of minutes, manual recon, they had a backdoor on the system. They knew it was an analysis VM, just exited, and nobody got nothing. So that's pretty disappointing for a researcher. Another thing is operation fingerprinting that's been done by Malwarebytes. It's the Angler exploit kit that fingerprinted the system with path names. They looked for shared drives, they looked for Active Directory, and things like that. So things that would normally be in a real environment. And if it wasn't, they just exited or put something else that wasn't as cool as you would expect.
Another use case I mentioned earlier is team analysis. So of course, as any conference-driven open source development, some things are left undone. So this is one of the cases. But it's just a matter of putting the right vagrant comments. So it's not even our tool's fault, because once the image is built, it's more a manage of a workflow. But I still want the workflow documented, and I should take some time to document it properly in the coming weeks. But the idea is you have your vagrant file inside of your Git repository. Your Git is associated with an investigation, and you can share your Git 3 easily. Vagrant file is only a text file. And the vagrant boxes are hosted on an any HTTP server. And then someone can clone your analysis tree and then vagrant up your analysis and be inside your virtual machine with the malware sample inside of it. So this is only a matter of time before it's documented in our repo. So how can you get this? You want this now. So I have an anti-vaporware statement to make. because I dislike most of the, not most, but often projects that are discussed at security conferences. You never get to see the code. Or academia is also guilty of that. They always say, yeah, look at the code, and then you need to send them a Twitter or shame them on Twitter to say, where is the code? And then they say, oh yeah, we just need to clean up a few things. It's been 1 year, man. Come on, clean it up. So what we decided to do is, we're tired of this trend in InfoSec, and we released the tool even before our talk. So like a few months ago, I created the repository. We committed all of the stuff already there. Yep. And you know what? Everyone should be doing this instead of hiding it and waiting to push the publish button. No one will find your kitten project, you know. Just do it in the open and deal with it.
And as you can see, it's on the Go Secure repo. Olivier has a couple of followers, and nobody noticed. We got nobody to talk about it. So basically, nobody cared.
No one told us our baby is ugly. So how does the thing work? Well, we call it mailboxes. So you use mailbox to build a profile, and then, I'm sorry, I'm stealing your slide. I see that.
It's okay.
Then it builds a Vagrant box for you, and then you spin a Vagrant file using, again, mailboxes to create a Vagrant file for you, which is tailored to your analysis. The available commands that, to customize the profiles are the following.
So yeah, that's what we have now. It has been implemented. Basically, the first four ones, registry, document, directory, package, are to customize the VM beforehand. So you create a profile that outputs a PowerShell script before you spin up the VM. So basically, you just, it's on the README basic commands. You just type mailboxes, registry, and then the arguments that you want, and it modifies the profile that you want to apply to the VM. And then you have build and spin. So build builds the VirtualBox image for the VM, and then you just spin it to create a Vagrant file that you can keep, and that's basically a link to the box, the Vagrant box, and then you just you can spin it up everywhere you want.
So let's look at the output of our previously built VM. Here we are, and so this is what happened. As you can see here, we installed like sysinternal tools and several like PuTTY and stuff like that. And this is all happened, you know, in the background without us having to do anything. And it's ready. Like you put in your sample, you create the port forwards for IDA to do remote debugging, and then boom, that's it. You have your new VM. I wanted this really accessible. So the way we build the default profile is, right now, the Windows 10 image is a Windows 10 evaluation version, so you don't even need a product key or a license. The license is okay for 90 days, and it's not. You don't even need to have the ISO file. I put in the URL of the ISO. So you do a mailboxes build of a Windows 10 analysis profile, and you will get half an hour after, depending on your download speed, a full Windows 10 VM evaluation with all the tools installed ready to infect. So I think this is really good to get new people started at malware analysis and be less scared of leaking stuff or being infected. So this is useful to reduce art and augment science. Get new people in malware analysis and improve workflow of seasoned analysts and teams. So where was harder to fit in these W's, but so we figured we should say, where is this headed? So we are going to implement anti-VM detection tricks. So this was not done yet. So it's, oh, the slides. Thank you, Laurent. People are really shy. So did I have any good jokes on the one before? Oh yeah, where?
Oh, it's good.
Yeah. So anti-VM detection definitely must go in there because VirtualBox is a pretty common environment to fingerprint for malware authors, like Hugo mentioned. We want to have higher level construct to build interesting targets. Active Directory integration is starting to be important. Some malware will not do anything if you are on an Active Directory environment. which is interesting. And the opposite is also true. So some crimeware will refuse to infect a company and will focus on home users. So it's a thing to have in mind. Generate honey documents based on a theme would be interesting. We want to document the team workflow, like I said, and this is all in the to-do. So if anyone here wants to look at it and hack on it, something that I haven't mentioned, I haven't tested it on Windows, so we definitely will have issues on Windows, but they should be all solvable because Packer, Vagrant, and all of the giants we are sitting on works on Vagrant. So with that said, let's get to work. If we want a fighting chance against the bad guys, we need to stop losing time on shenanigans like next, and building VMs. And we need to start sharing images. So if you have a Vagrant box that is one zip file with the sample and your IDB inside, you can send it to some analyst of another company and then work together and stop just like seeing these things as kitten and see it as the cattle that they are.
So just before the end, I wanted to thank some people that helped me. Joan Calvé for tips and help, thank you. Marc Etienne for suggestions, and he's the one that linked me to Olivier and made that possible. Julian Bremer, I worked on VM Cloak beforehand, and basically I think the new tool is better, so we're trying to work on that. Jose Fernandez for sponsorship, Jesse Campos for pushing me, and basically friends, family, and girlfriend for support, so yeah.
And I'm thankful to no one.
So any of you got questions, suggestion, tips?
This is our last train GIF.